Got a little bit of a delay, but it works. This is loud as fuck. On one side, it's in the test stand. So you can upload code now.
Yeah.
I think the only bad thing is though we need a function that after it processes, it should shut the solenoid. Because right now, like, it got stuck in a queue, and it kept one open.
I see, yeah.
You know?
Yeah, we could have a reset function.
It should be like, yeah, close all. Yeah, basically like level of craft.
Yeah.
Yeah, basically reset. Do you see it?
No, yeah, I was driving.
Oh, get on your phone, dog. I want to see what it looks like on the phone. Does this go down? Oh no, it's still alive. Huh?
Did you get rid of the formatting?
Well, the problem is that when I got rid of it on that page because on the, what's it called? Maybe I have that. I got rid of it because I was like fucking with it on display files. If you're using display files, like in the settings command, which is weird. Yeah. I'll add the little free tags back.
Oh, the free tag.
Yeah. Yeah, I got it. We have to add a command that like closes everything after it's done. Because right now this is like almost as annoying as the fucking stupid vacuum. Oh, is that a mega? Oh shit, dog! You gotta watch out. What's his name? Might steal it from you. I'm gonna reduce the pressure. Kind of annoying. I got like, I got a Zoom meeting in 10 minutes, so probably. Give me like 1 second. See.
A what?
A Zoom meeting?
What is that?
Up to you? So, I got a Zoom meeting
Okay.
in like 10 minutes. Wait, is that what it looks like right now? Or is that an old link?
This is the website?
No, it shouldn't
Oh, no,
be.
it hasn't refreshed yet.
Oh, okay. I was gonna say.
Yeah.
You just left it. Go get food.
Bruh.
Go get him.
Are you hungry?
What's that?
Are you hungry?
Why?
I was just given some free pizza.
Sure.
Yeah, okay.
Yeah.
Okay.
I'll take free pizza.
Okay. I think that's what it is. I don't know. Yeah, I have no clue what it is. But they said, here, eat before it gets cold. And I'm like, I'm going to drink beer. I want it. So let's see what it is.
Oh, you want to see? Oh, you want to see something cool?
I got a couple. Hey, I know what that is.
So this is a live feed of it. Or thought it was live. Oh, here we go. We got to skip forward to the live part.
Jesus.
So here you go. Now you can see my hand.
Uh-huh.
Right. So what you can do now, you can upload.
Yeah.
You
Not what I thought it would be.
Oh, that's not bad. You could upload code to it. It's kind of loud, so.
Shit, you know when somebody's on.
Yep. Yeah, exactly. So now, like, anyone on the internet can go on and basically try out the website and look at the code and everything. So, yeah.
You got some way to govern that thing?
What do you mean govern it?
And
Oh,
they
like
go left, right, left, right, left, right,
yeah.
left, right,
So
left,
right
right.
now it's more like just the people I send it to. There's no like web thing.
Nice logo. Who made it?
Which one, the left one or the right one?
Left one.
Some dude online for $25.
Excellent.
Right?
Yeah. Beautiful.
Oh. So yeah, so like if you wanted to go in there and you wanted to learn about it, you can hit, upload your own code, hit upload, and it does what you want. And like you can see on the live video, there's a delay, but like people understand,
Right.
It's not going to be instant. You're going to see what happens, you can see which one is currently running. And
Can
then
they
if
leave comments?
you can't leave comments, but that'd be awesome. But you could also see other people's code. So like if somebody was like writing something different, you could like see what they wrote as like hello world. This guy just wanted to print some stupid shit. And then like the next guy was writing actual code. Really, that's all you'll have to write is something simple like this, where you could say like thruster impulse and then like fire it. This means 15 times, like do the same thing 15 times.
Right.
And so that's why you hear the, and then like you hear the next one, which is just like open and then close. That's what these like few lines mean.
Gotcha.
So they don't have to know any of this information. They can just like look at this few documentation and start writing it. Like a kid can do it,
All right. Get them going.
Yeah.
That's cool. Who else knows about this?
No, just the guys in the lab for now. I don't want to. It's definitely hackable right now and fucked around with right now.
Okay, yeah.
Yeah. But you could show it to people, but it's not always live. Like I'm turning this thing off all the time to like play with it and stuff. Eventually, what will happen is that we'll go into a new ring, and then you can play with the craft.
Oh, yeah, you better put a governor on it.
Yeah.
It'll spin the heck out
I
of
know
it.
that's what I was thinking.
For some reason. Hi guys, do you hear me?
Yeah, we can.
Can you join Zoom in a chat? It's dropped. I'm sorry. Can you join, Daniel? Can you join Zoom? It's in the chat link.
Okay.
Yeah. So hang up here and Zoom there. Okay. Sorry about that, guys.
I don't. Oh, hold on. Okay.
the chat should be.
Yep.
I'm dropping the link. Perfect.
You know how to have Zoom go to your headphones instead of the fucking thing?
Can you just go to Bluetooth?
I think so. Oh, it's disconnected. You're good.
I'm not sure if you.
How do I change my camera now? What's up? I'm on mute. I'm on mute right now, but do you know how to change the video on Zoom? Anyone? No, like I have a different camera and video settings maybe. I'll show you something cool in a second if you want to see. I don't know if it's still running because I have like 2 webcams going at the same time.
Where's the other webcam?
Oh, so we have the spacecraft sitting over here, right?
Yes.
So now you can. I'm hearing like triple because it's echoing, but you can upload your code to it. So like some kind of like control code for fun or firing solenoids. And you could hit upload.
Okay, that's lit. I don't know what it just did.
You can open the door, please.
Oh,
Yeah. What's- I'm in a Zoom chat for our thingamabobber. Jack, do you need to hear it, Jack?
Yeah.
Okay.
I've done 0 of this.
Anyone else? Dan? Yanni? Dan, can you introduce yourself?
What was the question?
Can you introduce yourself?
Oh, okay. Sorry, that was. I've got like multiple webcams running at the same time. My name is Daniel Wolzak. I'm a senior. I'm from Chicago, Illinois. My major is computer science. Some of the things I kind of work on are neural network Python packages, or genetic algorithm Python packages to make it easier for everyone. If you Google EasyGA, you'll see the first genetic algorithm, and then EasyNN is another one. Me and Jack created. Well, we created both, but yeah, we just try to make things easier. I like programming, fun stuff.
Nice to meet you, man.
Yanni, Emily, can you introduce yourselves?
I'm an aerospace engineering sophomore here at WRL. I'm currently minoring in computer science and applied mathematics. And I took on this project because I saw a big interest in data science. I really want to work with data in the future of aerospace. I feel like it would be a super fun project to take on.
What's up?
And learn more about the pipeline.
Just coming to chill.
My name's Emily Google. I'm studying computational mathematics. I have a minor in computer science and homeland security. I took data science, intro to data science fall semester, and it was really interesting. And I wasn't planning on going down that path. Once I took that course, I was like, I definitely want to do this. So then Professor Berezovsky recommended that I take
Yeah, you can go. You can go to it. Let's go to easycontrols.org. No, it's just like what's running the application.
My name is Taryn Trimble. I'm a junior in computational mathematics, and I'm in the engineering track, and I'm also getting my physics minor. And I was just really interested in starting research.
It's still on. It's just
because I want to actually get my hands on something and learn something new and actually apply what I have learned the next couple of years, the last couple of years. Of course, Berezovsky was letting us know about the class, and I thought it was really interesting, and it kind of helps
Yeah, it did kill itself.
Helps us
I'm
into
on 2 different
490.
webcams
So
at the
I
same
thought it
time.
would be a really good way to just like get my foot in the door and just see what I'm interested in.
Who's Garrett Lee?
Perfect. And Jack, can you introduce quickly yourself?
Oh, Zoom chat. Hello, I'm Jack. I'm just using Dan's webcam and stuff. I'm a computer science and math major. This is my senior year. I helped work with Dan on many of his packages like EasyNN, EasyGA. I'm mainly focused in Python, and I love neural networks and AI and stuff. Yeah.
All right, so is that all the students then?
Yeah.
So that leaves me. Hi guys, I'm Jesse Adams. I work at the Nevada Security Site for the current contract holders, Mission Support and Test Services, MSTS. And yeah, I'm excited to hear. I couldn't quite hear Annalise. For some reason, your mic wasn't working well for me, so
how we had
I didn't hear what your major was, but it sounds like everybody else is computer science and computational math.
Think of this as like a really big ring.
And then one aerospace engineer, is that right?
That, and there's
so does everybody have
each ring has the ability
some Python coding experience then in this group?
Yeah.
Okay, that's awesome. I'm really excited about that.
Each 3 of them will sit in the ring, and then this will sit.
Yeah, I wasn't sure exactly.
And then what I just showed you, where you can upload code.
How much to start you guys off with, without knowing your
control itself will allow you to like add
with Python. How much baby steps I needed to give at the beginning, but it sounds like we're going to be able to start a little bit higher level than that with this crew. So that's really great. So yeah, I sent you guys a document and hopefully got a little bit of time to read through it. I know you guys had sent me some questions. So just a quick kind of refresher, I guess, if I can pull it up on my end. The basic idea of our project here is we're really wanting to look at ensemble neural networks and then see if we can do some uncertainty quantification.
You raise your hand
with these networks. So, I mean, I know some of you sound like you're pretty familiar with neural networks, and they're often kind of talked about as a black box, right? You have an input, it spits out an output, but kind of whatever happens in between is pretty magic, and it's often pretty hard to quantify what's going on in there, or really have a good understanding of what's happening in between the input and the output. So we're wanting to do some UQ to be able to get some actual like quantified information on, given an input, what kind of things can we expect on the output. So let's see. I'll look at your questions, and I think you guys are all in the email with the questions that were sent to me, right? So if I just read the question number, you guys would know, or should I read out the question?
Did we get it?
I
don't know if
you
we got the
kind
email.
of like go. Yeah. I don't know. Just answer in general, or you can read if it's required. Probably, yeah.
Okay, so yeah, so the first question, and then there was a few other questions later on. I'm assuming these were all just kind of from different students. Was about the data sets. So I kind of purposely didn't provide you guys a data set because I wanted to give you an opportunity to find a data set that you were interested in working with. So all I'm requiring is, I thought we would start with a 1D data set just because that'll make things computationally more feasible. You can run neural networks on your laptop rather than, sometimes when you start working with images, it requires more computation, which, I mean, it sounds like with this crew, maybe we might be able to get to that level later on in the semester if you guys are strong coders. But starting with 1D data sets, I have a couple of links. I can send one in the chat, just of a repository of different data sets that I found. is everybody able to see that chat that I sent?
I mean, just
So let me pull it up so I can talk at it a little bit too. I have it somewhere. So this is just a repository of different data sets. All I'm going to require is that in the task or the default task section, that we have a regression data set. So what that means is our output, we want it to be some sort of number so we can do regression on it rather than classification. So classification problem is like, is this a picture of a cat? Yes or no, right? Or this is, maybe you have different classes like cat, dog, bird, whatever. Whereas regression, you're given a number as your output. So that's the only stipulation we're gonna have for a data set. So you don't have to choose from those ones. If you find another one that you guys would like to work with, that's great. If you guys know of some other data sources, by all means. I want it to be a data set you guys are excited to work with.
It's not a category.
So yeah, I wanted to leave that part up to you, but if you want help choosing one or if you want me to just choose one for you, we can also do that too.
It's not a big deal.
I was going to say, what's the difference between that and like a classification problem?
What makes the variable striving method more
I know like the data set's different, but like how the process
is variable strive is an approach to manipulating pooling layers in a convolutional neural network for image data. So the idea was to kind of make it be able to focus on a certain part of the image if that part of the image is more important for whatever you're trying to process with the neural network. And if you're able to focus better on the part of the image that's more important, that can increase efficiency in the network. Whereas when we're talking about neural networks, efficiency means correctness in the output.
EasyControl.
Next question was, when referring to sources of uncertainty,
down right now. Like
can you elaborate on what types of different data should be used to
I'm going to make it
uncertainty
like
quantification, or what makes a source partially uncertain? So when we're talking about uncertainty in data, that generally means sources of noise. So if we look at the radiography example, which is a big data set that we have here at the NNS, we take images, radiographic images with a big X-ray imaging system, and there are multiple sources of noise in that. The X-ray beam isn't a point source, so that causes some blur in the images. X-rays can get scattered off of everything. That causes more issues. The way we turn the X-rays into light in order to catch them as an image is via something called a scintillator. That also adds some noise because of the way the scintillator converts X-rays to photons. Our X-ray isn't monoenergetic, so there is also some issue there.
No, they're using real data, right?
And I mean, that's just those are just the main things. There's even more things. So it's going to be very data dependent.
But isn't uncertainty just like
and we might have to think about
like error is like an uncertainty quantification?
The noise for whatever data sets we want to look at would look like, but I mean, there's definitely going to be noise in any data.
Do they want noise in the data?
And so, that's kind of on the input side. So we kind of want to know, I mean, in uncertainty quantification, given some distribution of noise on our input, what kind of effect does that have on the output? So you can think of that as, if we want to get into kind of math terms. So if we think of our truth being X, right? And we have some function f of X and our output is Y. Well, what happens if I, let's say, multiply X by some random variable eta that's close to 1 and maybe add another random variable epsilon that's also, or that's close to 0. So I have eta X plus epsilon should be really close to X still, right? Because I'm multiplying it by something close to 1, adding something close to 0. what happens when I apply F to that? So F would be like our neural network. If I take F and then apply it to, and instead of just giving it X, give it epsilon, or sorry, eta X plus epsilon, what's my output Y look like with respect to just F of X?
So you want like a
Does that make sense to everybody?
Like, what's the difference?
Hopefully that was
Is that what it is?
okay to follow without me having something written down. So yeah, we want to characterize our output based on the distributions of the random variables that we have in our input.
Saying
I
random.
asked about data augmentation right now.
Next question is the provided
Is he
data set all
asking us to do
collected
data
through X-ray
augmentation?
radiography?
Is that what you're saying?
So we probably
about
won't be
it.
looking at the radiography data. The radiography data we have is 2D and pretty large images. So that would definitely be computationally expensive. And also the unfortunate side of working in the area that I am, I have to get everything publicly released in order to get it to you guys. So getting a data set that's like large enough to be useful in neural networks would be kind of difficult to get to you guys. So we probably won't be working on our radiographs, but like I said, it sounds like we got a good group of coders here. So
if you could give us a data set similar to the one that we would use, like a publicly
work on some
available
image
similar
data.
one.
There are definitely image data sets that are publicly available that we could look at later on in the semester if we're moving at a fast pace.
Oh shit! No, I don't want to give it for.
Next question was, where did the physics applications come into play, or how are the results physically interpretable? So again, that's going to be really data set specific.
I have a question.
Oh, go for
it. Is there a data set that you can give us? I know you said that it wasn't publicly available, the one that you would actually be using, but is there a data set that you can find that would be, if not very, very similar to the actual? I don't even like it, even if it's not even close like to what it is, but like the same type of data.
You can check it out. Diabetic retinopathy data set on retina. That's what another project with NNSS was working, and Marlesa told that it's features that they're looking in X-ray and in retina are kind of the similar, but it's kind of clean. I have a small data set that is clean. It's easier to work, or you can go on Kaggle, and I also can send you a link for that.
Yeah, actually, I do have an image data set too that I could send you guys to. That's different than the retinopathy data that I think could potentially work better if we're going to end up using a 2D data set later on. Yeah, for sure.
Okay.
I can email you guys that after this.
That's even better. I'm sorry. Yeah.
No, that's fine.
And then, do you have a question or no? No. Okay. That was it. Thank you.
Yeah. And yeah, please chime in if you guys have more questions while I'm answering these. Okay, so the physical interpretability question. So that's very data dependent. So I mean, specifically, I can give an example with the radiography images. We're like actually interested in the density of the materials that we're taking radiographs of.
This one's
so
maybe this one's better.
You can make some models and make some assumptions on symmetry of objects.
Yeah.
And in doing that, you can then take the pixel intensities and translate those into material densities.
Crazy.
So I mean, that's just an example for that data set. But yeah, the physics applications or and interpretability will depend on what the data you are actually looking at is.
Maybe later.
Okay. Next question was on the data, so we kind of covered that. Currently developed neural networks have implemented the variable stride method, and what were their flaws? Like Professor Berezovsky said last year, we had a group of embry-riddle students working on the retinopathy data set and implemented variable stride there. We had a summer intern work on another data set, which is the one I was just mentioning that I can email to you guys as an optional 2D data set. And then we also have some data on the classified side for us that we've implemented a neural network that has variable stride in it. As far as flaws, like I said earlier, flaws in neural networks can sometimes be difficult to pinpoint depending on how you're defining flaw, just by the black boxy nature of the neural networks, and especially with deep neural networks. So that's kind of why we're interested in doing the UQ, right? To see if we can get a little bit better understanding of what
wanting quantitative reasoning
these neural
why
networks are
make
providing
decisions.
us as outputs.
I don't understand why everyone is so fixated on that. We don't quantify neural
Next
networks
question
based
is
on
how are smaller
individual
neural networks
decisions.
implemented into
Say
larger
how
scale
good are
networks
they
such as ensemble
99%
networks?
of the time?
How effectively do they perform? So I wasn't quite sure what
so the
you're going for with this question, but
a little bit different.
so hopefully my answer answers the question you were trying to ask. But generally, it's relatively easy to combine different neural networks. You just need to make sure that your inputs to those neural networks and outputs from those neural networks get combined in some meaningful way. So if you have your neural networks in series, so you have neural network, and that's kind of like a deep neural network framework. As long as your input and output sizes make sense
run the neural network
and match up, then
multiple
that's kind of all you need to do.
Almost like a for loop, basically, of seeing
and if you're combining things in parallel, which is kind of what the basics of an ensemble neural network are.
So it's different than the 99%.
And there's a cartoon ensemble neural network in the handout I gave to you guys. You just want to make sure that the thing, the combining piece, it has like a little brain symbol in the handout, combines the outputs from each of the separate neural networks in a way that makes sense. So performance is also going to depend
cares how you got the fucking data
on how well you train the network. So generally, when you're working with a neural network, you have some sort of a subset of your data that is your training data, and you use that to train your neural network. And there's a question about that later, so I'm gonna wait, talk about that a little bit more.
That's a good question. Number 15.
There's another data question.
Thoughts.
Number 9. So, yeah, we can talk about, or kind of talked about data already. Number 10.
Oh, does it need to be normalized? No, or cleaned? That's a good question.
Is asking about the post-processing for Cygnus. So, I guess in the interest of time, I can come back to that one since we won't be using Cygnus data specifically. That one's not super relevant, but I'm happy to give you
question for the last 3
rundown of that. It is an interesting problem. Just not probably what we'll, what you guys specifically will look at. I will look at it a lot, but your data probably won't. You won't need to know the specifics. What are we training the subclass of neural networks to do? So that is ultimately going to be depending on what the data is, but generally when you're training a neural network, you're giving it a set of known inputs and outputs, and you're feeding in the inputs and saying this is what the output's supposed to be, and that's what training the network means. It's you're providing it a correct known set of inputs and outputs, so that you can then, once the neural network has learned what inputs correspond to different outputs, then you can feed it other inputs and hope that it provides a correct output.
you check the
when it
values
doesn't know what the
left to
output's
right.
supposed to be. Right?
It's actually an array of values, and you check which one between you go down to, or if you go left to
Next
right.
question: what are the desired
What's the
outcomes of the finished UNN
The difference
architecture?
is that it
i.e.
has
what
more
units
per node.
will it be measured in? What will it
Values.
mean? Again,
Each
that's
step.
going to depend on the data sets that we look at. Like if all I'm wanting at least first is some sort of regression data set. So we're going to feed it in some set of numbers and output. We want the output to also be another set of numbers so that we can do regression. What is the desired UQ for the architecture? Again, this is very data dependent. UQ just requires you to have some sense of the probability distribution of your noise sources. So different data will have different noise sources, and those will have different probability distributions. So we'll be able to talk about that once we have data sets chosen, but it's going to be dependent on our underlying problem there. What are ensemble neural networks usually used for at the NMNSS?
Everything, anything.
So,
what's the difference between that and that?
No, we're still going like this value left to right, this value left to right.
Does he?
Isn't it, no. One more thing. What? Did you say something?
Just it.
No.
Okay, we lost. Oh, group ID. So guys, do you hear me right? Yeah? Okay, cool. Okay, we will wait for Jesse come back. Meanwhile, so again, update everything. I mean, your questions, considering right now, it's kind of more clearly there. If you need confirmation on anything, right, just like making sure you understand that's why our presentation on, right, and feel free to go and ask. Oh, okay, Jesse, you're back. You are muted.
Yep.
sorry, everybody. I think my internet died for a minute there.
Yeah.
Isn't there something
where
in
did
the tree
where'd you
that
lose
says
me?
like you could check the
Number
depth in what you
14,
search?
right? Well, then someone that are using. So
like you search the first one, right?
It's 14.
And if you
question
like
14.
that one,
It's
you
on the
keep
shared
going
screen
down
as
the
well.
tree,
So.
Yeah.
vice versa.
This will actually be kind of the first place, at least within the small group that I work in, which is the math group here at the NSS, where we'll be playing with ensemble neural networks. So you guys are helping us start using them here.
The two items.
Is the project focused more on uncertainty quantification or the application of ENNs? I would say it at first we're going to focus more on ensemble neural networks, and
you can store
once we have a good hold on that and we're happy with our network structure, then we'll start focusing more on the uncertainty quantification. So it kind of depends on how far
you're not loading nodes
we get throughout the semester. Like I said, it's going to depend on a lot on you guys, how this gets paced and your abilities. So I would say it's, definitely both, but first it'll be more on the neural network side, and then later more on the uncertainty quantification side.
Actually, just help to write.
Are there specific input values being used for this project?
Ooh.
Okay, so yeah, again, that will depend on the data sets that we decide to look at. Does the data set need to be normalized, cleaned? So again, this will depend on the data set, but I just wanted to say that I really like this question. Data sanitization is a really important part of data science, so that's a good thing to be thinking about. And especially with when you're working with neural networks, it's really important that your training data and your test data have correct input and output pairs. So you know the thing you're training with, all that data is correct, and the data you're testing with is correct. Another thing that comes up with neural networks a lot is you need to have your images be all the same sizes, or if you're working with 1D data, the signals need to be
all the same size.
the input signals need to all be the same size. So that's a really good thing to be thinking about, and it'll depend on the data set we decide to work on. Are there any obstacles expected from the project other than the initial learning and understandings? I would say that combining uncertainty quantification neural networks is a relatively open area of research. So I would say one of the obstacles is it's probably going to be hard to find a lot of resources that are for both of those things. There's a lot of great research that's done in UQ. There's a lot of great research done in neural networks, but combining those things, there's some stuff, but not a ton. So I would say that's probably going to be the biggest difficulty here.
But it works.
Is that yeah. Next question is, will the product be a continuation of variable stride method, or is the document given just helping understand? So yeah, so this will be different than last year's project, which was primarily focused on variable stride, but we might use it, or I mean, potentially use variable stride as part of our neural network, but that won't be the main focus. The main focus will be on the ensemble neural networks and the uncertainty quantification. I mean, variable stride has to be using image data anyway, so that's only if we end up getting to a 2D data set point.
Should we ask if
do I mind if the source code is open source? Definitely not.
You have to.
I'm a really strong proponent of open source code.
Just have CNNs,
and that's part of the reason why I want to
otherwise you have no
have you guys be using an open data set too, because then we really don't have to worry about the code sharing. So we have to be clustered on servers. So again, I talked about this a little bit. Well, since I wanted to start with 1D, just so that you guys can run this on laptops and stuff, but definitely, I mean, if we want to run this on servers, and if you guys have that available to you at your school, you can. That's awesome and good stuff to learn and a great resource to take advantage of. So yeah, we can look into that if that's of interest. And then, will the project have any specific application? Ultimately, yes. Here, we will definitely be using this for a few different, like both 2D image processing and 1D signal processing problems that we have at the NNSS. So, I mean, we will definitely be using what you guys help us create this semester. So hopefully I didn't go too over time and answered all your questions.
Ask if
I just want to see
dense neural networks.
I have a couple questions. One, I didn't hear what you said about is the source code going to be publicly available, and it won't be like you guys don't have any like requirement on it, right?
No, public availability is great.
Okay, perfect. And then,
yeah, no problem with open code.
Okay, and then what was your
dense neural networks?
So I guess CNNs can be made in multiple fashions or flavors, I guess you can call them. Do you want to have dense networks in there, or dense layers, I guess, in the CNNs, or do you purely want it to be
for the 1D data set?
For the 1D data set.
I think. I mean, yeah, I think. Well, like eventually, yeah, definitely, probably be working with dense networks. We might not start with that right off the bat. It might be just to make sure everybody's following along. Might start with some more simple network architectures. But yeah, I mean, for sure, if you guys, especially, I mean, it sounds like a couple of you guys have maybe a little bit more familiarity with neural networks. Like, if you want to throw something together that's crazy and super deep, then
sweet,
that'd be great. Yeah.
So
so network architecture is definitely going to be up to you guys a bit.
Yeah, I think there will be a small. It's not a problem, but again, I'm designing this code. Not code. Sorry, projects specifically in collaborative teams, but to make possible to everyone to progress. All right. So, but it's obviously that Daniel and Jack are way more mature than everyone else. So I will let them go crazy and as far as possible, because that's, again, we want this project to be useful for everyone and for you guys and NSS as well, right? So let them dig deeper, and all others will progress, and we will use them as technical support for others and help. And also, guys, I don't want you just gave a codes for other students, just like, take the code and like, it's working, right? So don't bother us, right? But again, I want everyone out of this course, right, to be able to create their own neural network and understand how it works, right? So they'll probably work on different bases, and it's good. And again, guys, some of you do not understand that work, but saying it is fine, right? It's a learning course, right? It's not a project, right? So don't be confused, but it's for me, and Jesse will be a little bit hard to push it uniformal, right? But we will manage it. I manage it a lot, so it's not a big deal. So yeah, and Daniel and Jack, please again proceed. Build as crazy neural network as you can, right? So go for it, right? Who can stop you? Unless Google, right?
Sparse neural networks.
Anyone else have any questions? And again, if you will need any help with choosing appropriate data set, you again can go and ask Jesse for directions, which one is better to use. It's 1D. 1D is very simple. And again, if you never build a neural network, there's a tons of absolutely amazing tutorials online that help you build your first neural network, and you can start there. I don't want to give you the link or something. You should find your way. Let's talk to you. Again, we have other students previous year build learn it from scratch, right? And neural network, traditional neural network, it's not that hard.
Like
it's literally 3 lines of code in the end.
From scratch.
I mean, code is deeper, but neural network is 3 lines of code because it's using modules. So don't worry about that. It's not crazy coding. All right, that's why people are going crazy. But always confirm. Feel free to write email for Jesse. You have his email. Official published on our internal website, where we communicate. So, and don't wait for confirmation. Don't wait for meetings, because we have our meetings going on, brainstorming. But if you are working, Dan and Jack, go on, shoot emails eventually. Just don't also be too much emails. We all busy people, so appreciate and pack your questions. Put not one by one, but send bunch of questions if you have at once, right? And give time to answer. Anyone else? Any questions? Any concerns?
I have a really good resource for anyone who's trying to learn neural networks. There's a PDF that I can give you guys. It's really a book that I purchased when I was starting, and it's like a super simple, like down to earth. It explains the math of neural networks and like how it works from a raw Python to switching to like NumPy, and then it kind of gives you like a gradual understanding of how they work, more than just like a literature way of doing it. So if anyone's interested, I could either start a Discord chat or I could put it out to Dr. Borofsky, and then he could send it out. But
yeah, I was gonna say, if you guys use anything like Discord or Slack or something, that would also be a good way for you guys to get questions to me, and I can just check that periodically too. So yeah, if Discord is something you guys use, then you can just throw me on that as well.
You can make it if you want. Yeah. Okay. I'm lazy.
Do you want us to start the Discord server and then we'll send you a link? Or
yeah, sure, that'd be great.
Okay.
Anyone else, guys?
Well, thanks a lot, guys. It was great to meet you guys, and I'm excited. It seems like we got a pretty good crew.
Indeed. Thank you, Jess, again, to agree to help us with NSS. And yes, Jess, I also will follow up with you for the next meeting. I think it will be like in
is it NNSS?
I'm not sure if it will be next week or in 2 weeks. Okay. I will send you. We will have meetings on Thursday with students, and then I will follow after that with you, and we schedule it ahead of time.
Thank you.
All right, guys. Thank you,
I'm
Jesse.
putting a
Again.
link in the.
Nice to meet you guys.
I'm putting a link in this
Yes,
chat
thank
right
you.
now for the Discord.
Thank you.
Thank you. Okay, great.
Everyone, join Discord as well. Right.
Oh man. Okay.
All right.
How do I? How do I? What was I doing?
Oh, the link.
That was to you.
Oh, you can just. Oh, you could have just DM me.
Oh.
You
Oh shit.
Oh, okay. Okay. Anyway, so skip lists.
Where are you? What the fuck? I haven't sent you an email in forever.
Skip lists.
Skip list.
Skip list.
Okay.
These are
I'm gonna yeet myself from this chat.
okay. I guess we're done.
Should I just give everyone like admin access to like?
Oh yeah.
Did he say something?
Please just say bye.
Many things are open at the same time.
Anyways.
50,000 links later.
So suppose you have a linked list, right?
No.
And these
Yes.
values are just 0, 1, 3, 4, 5, 9.
Hold on, give me 1 second. How do I?
You just refresh the page.
No. It doesn't work for this page.
You just end the stream and do it again.
No, I need to just change the camera.
Nah.
Oh, your connection is unstable while we reconnect.
How's that class?
Okay, but yeah.